Hello again. We've got a bit to get through today, so let's start with today's Scotch single malt whisky. It's the Glenrothes Alba Reserve, Alba being Gaelic for Scotland. It's another non-age statement whisky, which are becoming a little bit prevalent. It's very expensive to put whisky away for 10, 15, 20 years. And so a lot of distilleries are bringing out very young distillations, haven't been in the cask for very long, in order just to get volume up. It's all right for some of the younger, just starting up distilleries, such as Kilhoman, but some of these older distilleries are perhaps getting a little bit too greedy. This is what Jim says about it, and he sort of sums it up. The Glenrothes Alba Reserve, 87.5. You know, that smartly groomed, polite but rather dull chap you invariably get at dinner parties. The problem with didactic presentations such as these is that people are likely to get the impression that you're teaching grandmothers how to suck eggs, and the British comedy scene is very good at parodying this whole issue. The Monty Python team, Michael Palin, famously parodied the Blue Peter children's program. Today we're going to learn how to split the atom. The Young Ones team, Neil, the hippie, was telling Rick, the late Rick Mail, that we sow the seed, nature grows the seed, and we eat the seed, and then we sow the seed, the glorious circle of life that this involves. And that in turn was a parody, or a homage really, to Peter Sellers in his last movie, Being There, where Chauncey Gardiner talks about the seasons, which in itself is a homage to the Proverbs, to everything. There is a season, turn, 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 and a time for every purpose under heaven. We all know the big picture. I'm not trying to tell you anything that you don't already know. If you look at Wikipedia, you very soon realise that there's a lot of knowledge out there, and we only ever glimpse a small part of it. But the what we can do is put together syntheses of this information. So if we look at a typical book these days, we'll be looking at this in a moment, Radical Abundance by Eric Drexler. In the back of these books, of course, we have pages and pages of references. In Eric's case, there aren't very many references because he's quite an original thinker, but most books are a synthesis of ideas, so like taking a large number of ideas and putting them together in a little bit way, like a jigsaw puzzle, so that a picture emerges. Despite what Jim says, it's actually quite nice. So everyone, or most of us, know the big picture. We live in a universe that's 100 billion light years in diameter. Strangely, physicists talk about a four-dimensional universe, but whenever we talk about the universe, it seems to be a sphere, a three-dimensional object. Nevertheless, there you are, 100 billion light years across. Pretty big, a lot bigger than the Earth. But we've got our little planet to take care of here, and I like to think about describing a picture of that planet going into the future, where there is a future, and we can start thinking about how we're going to keep persisting on this planet for the next 1,000 years, the next 100,000 years, the next million years, the next billion years. To do that, we have to have a sustainable economy, and Eric Drexler, who started writing in the mid-80s with a famous book called Engines of Creation, has spent his life attempting to encourage scientists and research and development to pursue what he calls radical abundance. The world and its problems ultimately come down to how much stuff everyone has, and so his solution is quite simple: give people lots of stuff, make abundance in radical amounts available, and people will start not think about the material aspects of life and start focusing on the spiritual aspects. The amount of stuff that we can get through radical abundance is a corollary. I mean, we'd all like to have a nice house and a nice car and lots of fancy objects and all the things that money buys. But Eric's main thrust of his argument is to do something about the carbon pollution in the atmosphere, which is the most pressing issue in terms of the longevity of Earth. Carbon dioxide in the atmosphere is a little bit, according to Eric, like water entering a bath. We have a bath, the plug's in there, the tap's dripping, we're putting all this carbon dioxide into the atmosphere, we're filling the bath. And if we were to reduce our carbon emissions, as we talk about doing at climate change talks, what we're really doing is merely turning off or turning down the tap and reducing the amount of water that's flowing into the bath. We're not actually doing anything about pulling out the plug. And so the 350 was a figure that was targeted by Bill McKibben and his organisation. That's now risen well above that, and we're above 400 parts per million carbon dioxide. The bath is full, it's flowing over, and we need to do something about emptying it. Now, it's taken 200 or 300 years of industrialization to burn all of that coal and petrol and to produce that carbon dioxide that's in the atmosphere. In combining carbon with oxygen, or oxidizing, burning carbon and producing carbon dioxide, we release energy. And basically, in reversible physical processes, you need to put just as much energy back into carbon dioxide to split it back into carbon and oxygen, which is what, of course, plants do, but we've put so much carbon dioxide in the atmosphere that the plants don't have the capacity to do that quickly enough anymore compared to what we're putting out. So what we need is some way of sequestering this carbon dioxide in underground fissures and cavities under high pressure as a stopgap until such time as we have the resources to break down the carbon dioxide and remove it completely from the atmosphere, so that we have a better potential of going forward with this planet. To compress, to reduce, to take carbon dioxide out of the atmosphere, you need pumps. Basically, you need to compress the carbon dioxide so that it cools, so that you can separate it from nitrogen, oxygen, and all the other components of the atmosphere. And then once you've separated that off, you can then easily just pass it through into these underground reservoirs, which are very stable and can hold it for a long time. And pumps cost money to make. They have components that are quite complex, and we need to make a very, very large number of them at a very, very cheap cost. So Eric first looked in the 1980s at nanotechnology. In this book, Radical Abundance, he bemoans the fact that his term that he introduced, nanotechnology, was hijacked by business. They saw a sexy term, thought they can apply it to anything, and strictly speaking, suntan lotions do have nanoparticles in them, but nanotechnology is not about nanoparticles so much about atomically precise manufacturing, or APM as Eric calls it. That is, in every object that's being manufactured, every single atom is placed in the structure of the object that's being produced in a precise way, so that each atom is accounted for in the manufacture. So, atomically precise manufacturing is a very large piece of this simple jigsaw puzzle we're trying to put together here. And Eric describes a manufacturing plant, which is not necessarily exactly how it would work, but it's a way of illustrating the sort of principles that he espouses. And it is to imagine that most objects that we purchase, even components of houses that are built, obviously not houses themselves, fit within, say, the size of a average size garage for a car. So imagine a manufacturing facility that consists of a garage, and if we look inside that garage, at one end of the garage we have the door, and at the other end we have a matrix of 10 by 10 compartments, or 100 compartments at the back of that garage. And in those compartments are the 100 components that make up a final object that we're constructing. It could be a car, it could be a mobile phone, it could be any object that you're wanting to manufacture. Along the sides of the garage are two robot arms that can move backwards and forwards, up and down, in and out, and they can access each of the 100 boxes at the back of the garage. And so to assemble an object, each arm goes to the back, picks up object number 62 and object number 51, bring them forward and assemble them, and then go and get the next object until the whole product is assembled, and then out it goes, the door, finished product. Okay, so what's involved in the boxes at the back of the garage is quite simple. It's a fractal regression. If you consider that each one of the 100 boxes at the back of the garage is in fact a miniature, 2 orders of magnitude smaller replica of, but in miniature, of the garage that I've just described, or that Eric just described. And so again, there are 2 arms, 100 even smaller boxes on the back of the wall of that compartment, and each of those boxes has an even smaller component. But the robot arms, smaller robot arms, go pick up the components, bring them up, assemble them into the subcomponent that we saw at the final garage. And this regression back to the very back of the garage wall continues until we have actually, at the back of the wall, we have being fed in molecular-sized components of the ultimate product being constructed. A little bit like ink being fed into a printer. So you've all heard of 3D printing, which involves more of a raster process, and usually 1 or 2 components, like a plastic or a metal, being deposited. So by raster I mean it goes backwards and forwards, a bit like our robot arms, but it does it in layers. So you start at the bottom, move up to the top of the object, and it all gets printed. This way we're actually feeding in and able to get much more precise complexity to the design. We're feeding in subatomic components into the molecular components, molecular meaning they're just a few atoms assembled. They get fed into the back, and they are the very first components that are picked up in the 100 boxes at the back, at the very back, first assembly hall of this machine. Because the surfaces of each of the final components in the end garage have atomically precise edges. If you imagine, normally if you mate one piece of metal with another piece of metal, you bring them together, you need to have a flange, you need to have bolts in which you bolt the object together and fasten it. But if you have two pieces of metal that have atomically precise edges, then the edge on this piece perfectly matches at atomically precise level the edge on the other piece, so that when they're brought together they fuse and they become as if they were one piece of metal or whatever the object is. And so this is the beauty of atomically precise manufacturing, is that there's no fastening required. Each of the components of any object, the object can just be divided into subsections that are then assembled at this final stage. The beauty about this production technique is that as you go further back into the back of the garage, of the manufacturing plant, the robot arms start moving quicker and quicker by orders of magnitude, because there's less weight that actually has to be moved backwards and forwards. By the time you get to the very back, they're just molecules which are extremely light, and so the actual manufacturing process becomes many orders of magnitude quicker, so that any object that you're producing, a car let's say, actually comes out of the assembly hall in 3 or 4 minutes, rather than however many days it takes normally to make a car. So this is one of the most important things we've learnt. Eric talks about how all of this technology doesn't require anything more than the standard model of particle physics. We don't require any new science, we don't require any new understanding of atoms or how they work in order to access this technology. We just have to have the will to make it. His first priority is to get all of the carbon dioxide out of the atmosphere, but the corollary is that with radical abundance we can start thinking seriously about producing so much stuff, producing so much wealth. A little bit later on in another one of these in the series, I'll talk about the difference between services and products. Products are real stuff that we consume, that we use, that we need. Services are becoming a little bit like a product that doesn't exist. But I won't go into that at this stage. So thank you today for spending the time to watch this, and hopefully you'll look forward to the next video. Thanks.